Hi everyone. In today's challenge, we are going to solve this problem. The problem name is number of longest increasing subsequence, and the problem number is 673. Alright guys, so first of all, we are going to clearly understand the problem statement. After understanding the problem statement, then we will move to the logic part. And in the logic part, we are going to see how we can solve this problem. What is the logic we are going to use to solve this problem? And after understanding the logic part, then we will move to the implementation part. And in the implementation part, we are going to implement our logic in Python, C++, Java, and JavaScript programming language. Alright guys, and guys, if you want to have a look on the solution which I'm going to write in this video, I will share the link in the description. You can go through that particular link and you can find all the solution which I'm going to write in this video, right? Now guys, let's see what this problem says, right? So problem says, given an integer array nums, return the number of longest increasing subsequence. So guys, we are given first of all one array, that is clear, right? And that is also going to be integer data type, right? And the name is nothing but nums, right? Now what we need to do in this array, we need to return the number of longest increasing subsequence from this particular array we are getting, right? So simple thing guys, first of all, let's understand the longest increasing subsequence. What is this? So let me take one array, 1, 2, 3, 4, right? So this guys, you can in this array, you can see guys, the 2 is greater than 1, right? 3 is greater than 2, 4 is greater than 3, right? So that means nothing but this is in an increasing order. First thing is clear, right? If it is in increasing order, so if any subsequence I'm going to take, this is also in an increasing order, right? So I can say this is nothing but in a increasing sub, we can say subsequence, right? So this is one increasing subsequence because whole array is also subsequence, right? So this is an increasing subsequence. If I just write any other number here, 6, so you can see guys, 6 is greater than 2, but 4 is not greater than 6, right? So this is not an increasing subsequence. So we need to find just such subsequence from our given array such that all the numbers should be greater than the previous number, right? 2 is greater than 1, so all the numbers should be greater than the previous one, right? So this is called increasing subsequence, right? Now we need to find the longest increasing subsequence count, right? We need to find the total number of longest increasing subsequence, right? So how we can do this? Let's see with example 1. So in the example 1, you have 1, 3, 4, 5, 4, and 7. So guys, first of all, you can see there are a lot of subsequence present which is in an increasing order, right? So 1, 3 itself is a subsequence, 1, 3, 5 is a subsequence which is in increasing order, 1, 3, 4 is also a subsequence, right? So we have a lot of subsequence, but the longest is nothing but if you focus here, the longest is nothing but 1, 3, 5, and 7, right? So this is nothing but the longest increasing subsequence here we are getting, right? It is length is nothing but 4, right? And you can see guys, the subsequence of more than 4 length is not present, which is increasing one, right? So there is only one subsequence of 5 length, that is nothing but whole array, and where you can see 4 is greater than, you can see 4 is not greater than 5, right? So this is not a increasing subsequence. So we can see the longest increasing subsequence is nothing but this one, which is having a count is nothing but length, or we can say length is nothing but 4 only, right? Now we found the longest increasing subsequence. Now what we need to do, we need to find total longest increasing subsequence. So we give a name to its the longest increasing subsequence just because it has a length 4, right? So we need to find one more or more subsequence which have a length 4 only, but that should also be an increasing order, right? So guys, if you will focus here, 1, 3, 4, 7 is also of a length 4, and this is also an increasing order, right? This is also is increasing subsequence. So we can say we found two subsequence which is having a length is equal to the longest increasing subsequence, right? So we have to return this count too. Simple term guys, I hope you understood this. And also you can see here we got output 2. That means nothing but we got two subsequence which have a length 4, which is nothing but equal to the longest increasing subsequence length, right? Now let's see the second example. And I know guys, if you did not understood, don't worry, we are going to understood in detail with the logic part, where we are going to see how we can find this, all these things, everything. Don't worry about that, right? Now in this example second, we have 2, 2, 2, 2, 2. So let's write all these things, 5 times 2. Then here guys, if you find a longest increasing subsequence, so here in the notice also they have given that sequence has to be strictly increasing, right? So if you find here longest increasing subsequence, so you end up with only one value, right? Because if you take any other value with this subsequence, if you take 2, 2 or anything, you can find that this is not in a longest increasing subsequence because 2 is not greater than 2, right? So only subsequence which is in, we can say longest increasing subsequence is nothing but 2 only, which is having a length 1. Now we need to find all the subsequence which is increasing order and has a length 1. So we can see this one, this one, this one, this one, all we can take separately, right? This 2 as well separately, this 2, this 2, and this 2 as well. So all having a length 1. So we can say we found 5 subsequence which was having a length 1, which is equal to the longest subsequence, longest increasing subsequence length, right? So I hope it makes sense. So we are going to return to one answer 5. And guys, if you did not understood, don't worry. Let's move to the logic part, and there we are going to understand how we can solve this problem. So we will have a better understanding, right? So we have understood the problem statement. We are given just one array. We need to find longest increasing subsequence count, right? How many longest increasing subsequence present in that particular array? Now let's move this and let's move to the logic part. So we are going to understand the logic in detail, but not like you will have a better understanding once you understood the logic part, right? So let's write a logic and let's take a first example only. We have 1, 3, 5, 4, and 7. So this is nothing but our array, nums array. Now we need to find longest increase subsequence count, right? So guys, how we can do this? So first of all, we need to check two things, right? First thing is nothing but what is the longest increase subsequence count length, right? After that, we need to find all the longest increase subsequence with that length, right? So this is what we were doing in the understanding part, right? So I can make one array, count array. I can say count array. Initially 1 1 1 for each one. So count array will tell us that how many counts of that. Let me just remove this one logic part here and let's say this one here, or let's move to below here because I don't have much space over there. So we were having an array this like 1 3 5 4 7. This was the array which we are given, right? And we have a counts array. This is nothing but 1 1 1 1 and 1, right? So this for each number we have a count, right? So this is count array, this is nums array. Fine. And now guys, what we are going to do, we are going to say fine, this is the case. Now guys, we are going to say you have this nums array. You need to find first of all longest increase subsequence, right? So initially I will say one more array that is nothing but I'm just writing over here only. So this is also having one value, this is also having one value, one value, one value, one value. So what they tell us that on this index we have a currently we have a longest increase subsequence of length 1. I hope you're getting this. So if you're not getting, don't worry about this. Let's say this is second index, right? So for second index, I have having a value 5, and there is one more value which is nothing but 1, which I'm just writing over here. So 1 is nothing but telling us that on second index we have currently longest increase subsequence of length 1, right? So I'm just having a 5, right? Not 1. I'm just having a 5, which is nothing but also itself a longest increase in subsequence, right? Fine. Now guys, let's traverse over this array and let's keep finding the longest increase in subsequence with these particular indexes, right? So you will find out better, you will find out easily, you will easily get this particular part once you go through this particular traversal, right? So I'm starting from this 0 index, right? So I'm here currently, I'm saying that with 1, I'm having a value 1, right? So is there any number present on the left side which I can combine with this one? No, there is no number present. So directly do this, right? Complete this. Let's move to the next one. So 3. So I have value 3. Is there any number present on the left side? Yes, there is a number present on the left side. There is only one number present, but yes, there is a present. So go to that number first. Yeah, we have 1. Now check. 1 is less than 3 or not? Yes, 1 is less than 3. That means there is a possibility to write 1 in front of 3. Does that make sense, right? So there is a possibility to write 1 in front of 3 because now it will also be a increasing order, right? I hope it making sense, right? So now if I write 1 here, so total length is number 2. So which is greater than this one, right? So just write here 2, right? And as this index having a count 1, so as I took the value from this one, right? I just took the value of this one 1. So I'm just going to replace the count with this one. So 1 is nothing but 1. You will understood this use case later on. What is the basically use case of this count array? But for now, just keep in mind that whenever we are adding a 1 into this or value, then we have to replace this count with this particular count. So this count will come here. This is nothing but 1 only, right? So there's no effect, right? Fine. So we have checked one value which is present on the left side. Now there is no more value present on the left side. So complete this part and come to this one 5, right? And remember guys, for 3 I'm just writing here, for 3 I found now 1 comma 3 array, right? So which is having a length 2, right? Now let's move to the 5 index, means second index which having a value 5. So is there any number present on the left side? Yes, there are 2 number present now on the left side. So first of all go to 1. So 1 is less than 5 or not? Yes, 1 is less than 5. So that means nothing but there is a possibility to write 1 in front of 5, right? So I can write like this, right? I can like this. So if I do like this, then what is the count I am having? A length I am having of this array. This array length is nothing but 2, right? So which is greater than this one, right? So which is greater than this one? So that means I can say just write here 2, and then replace the count with this one count. So count was 1 here, and if I replace with the one count, so it's still gonna be 1. So don't need to replace this, right? Fine. And is there 1 is done? Now come to 3. Is 3 is less than 5? Yes, 3 is less than 5, right? So there is a possibility to write 3 in front of 5, right? Is it possibility, right? And if you will notice here, 3 itself is not a single number now. 3 have a value 1 comma 3. So means 3 there is a in front of 1 as well, right? Right. So 135. 135 is nothing but we can say length is nothing but 3, right? 3 is greater than 2. Yes, 3 is greater than 2. So I'm going to just, and how you go to this 3? You don't need to keep storing this particular array today. You don't need to do anything else. You can see guys, if 3 is less than 5, so you can just take that count. That count is about 2, right? So you just have to add 1. So here this is nothing but this 1 comma 3 represent the count. That is 2, right? So just add 1, you will get a 3. So 3 is greater than 2. It is greater than 2. Fine. So that means we can write 3 here. And I have took the value of 3, right? I have took the value of 3 because 3 was less than that 5. So now I'm going to replace the count with 3 count. 3 count was 1. So if I replace, even replace, I will not get change. and this will not gonna change, so don't need to replace it, right? But for 5 now I got 3 length, right? I just write here that 3 represent that for 5 I have a length of 3, or I have a subsequence of length 3 which is in an increasing order, that is nothing but 1 3 5, right? Let's remove this one because we have taken all the number which is present to the left side of 5. So let's mark it check. Now let's move to the next one, 4. So is there number present on the left side? Yes, there are 3 number present. So let's move to the first one. 1 is less than 4, right? 1 is less than 4. So if 1 is less than 4, that means there is a possibility to write 4 in front of 1. 1 in front of 4, right? There's a possibility. So we'll get length 2. So we can say 2 is greater than 1. Yes. So I'll just write 2 here. And you can see, guys, there is a count replaced with the 1. So both will remain same. Fine. Don't need to replace the count. And now, guys, we are going to say, fine, 1 is done. Now let's move to the 3. Is 3 is less than 4? Yes, 3 is less than 4. 3 is less than 4. So there's possibility to write 3 in front of 4, right? And 3 itself not single. 3 has values 2, right? So that means there are 2 number present. So 3 and 1. So we are going to just write here, and you can see, fine, we are getting a length 3. 3 is greater than 2, right? 3 is greater than 2. So just write 3 here, not 2. And if you're increasing this count, you have to swap the count with the 1. So with the 3. So 3 count was 1. So if you swap even with this fourth count, which 1. So if you do like here, not swap, you just write 1 here. So you will not change anything. So that's why we are not doing anything here now. But for we understood that for 4 as well, we have a length 3, which is in an increasing order, right? For 4 as well, for this particular index, we have a subsequence of 3 length where the subsequence is nothing but in an increasing order, right? So which is nothing but 1 3 4. Fine. Now let's move to the next one. You will now understand each and everything with this button. So we are at 7, right? Now 7, we are at 7. Now we are going to say, is there any number present on the left side? Yes, there are 4 number present. So first go to 1. 1 is less than 7, right? 1 is less than 7. See, guys, here, focus here. This particular traversal is going to take a very deep understanding, right? So 1 is less than 7. Okay. So if 1 is less than 7, there is possibility to write 1 in front of 7. So if I write, I will get length 2. Okay, just replace with the 1 count. That is 1 only. Fine. Now we have this thing. Now let's move to the next one. 3. 3 is less than 7, right? 3 is also less than 7, right, guys? So I can write 3 in front of 7. So if I'm writing, see, guys, the length is 2, but 3 itself has a length 2. So I'm going to say this 3 have a 1 comma 3, right? So I'm going to say fine. So 3 1 3 7 length is nothing but 3. So 3 is going to be nothing but, we can say, greater than 2. So 3 is going to replace here, and 3 count is going to replace with the 7 count, which is nothing but 1 only itself, right? Now, okay, fine. Now 5 is less than 7 or not? So let's see. 5 is less than 7, right? 5 is less than 7. So 5 can be placed before the 7, right? So 5 we can put in front of 7. Fine. But 5 itself is not a single. 5 has a length 3. Means what are number present? There are number some present which is less than 5 as well. So that are 2, right? So that is nothing but 3 and 1. Right. So here you can see the count is nothing but 4 now. 4 is greater than 7. Oh, no, 4 is greater than 3. Yes. So replace 4 count is here. If you're replacing with 5, so you have to replace the count as well, right? So count of this I is going to be, we can say, replace with this one, right? So 1 is going to remain same. So 1 is here, 1 is here. So if you replace it, you will get a 1 over there. Fine. But now 7 has a 4. That means we have a subsequence of length 4 at the where at the index 4 we have subsequence of length 4 at the index 4, right? So that is nothing but 1 3 5 7, which is in increasing order. Fine. Now let's move to the next number, which is 4. Is 4 is less than 7? Yes, 4 is less than 7. So what that means, nothing but we can put 4 in front of 7, right? So we can put 4 in front of 7, and there are few number present also. 4 have a value 3. So which is nothing but 3 and 1, right? 4 have value 3. So which is nothing but we can say 4, right? Length is total going to be 4, right? So now we can say, guys, length is 4. Is 4 is greater than 4? No, 4 is not greater than 4. But it is equal than 4. Now the logic come here. It is equal than 4. So what that means? That means we found a subsequence of length 4. We found two subsequence. We found two longest subsequence. I'm again repeating. We found two longest increasing subsequence of length 4. Right? So if we are finding, just we need to keep count, right? So if we are getting an equal to 4, then we don't need to replace any count. We just need to add this count, this 7 index count, this count with the 4 index count, which we are just currently comparing. So it's counted 1. So we have to add this count 1 here as well. So we will get nothing but 2. Now all the numbers are completed, which is left to this 7. So let's come mark this check. Let's move to the next number, but there is no next number present. So we complete our traversal. Now once our traversal is completed, now you can see, guys. So here if you will focus 1 2 3 3 4, which is greater 1? 4 is greater 1, right? So that means nothing but we have a longest increased subsequence of length 4. We have one subsequence, longest subsequence, whose length is nothing but 4. Fine. And how many times that subsequence come? That subsequence comes 2 times. Simple. That subsequence come 2 times. So we have to return nothing but answer 2. If there is one more let's somewhere present 4, so we have to find all the subsequence which are coming 4 times, right? So there may be the case, guys, that in next we are getting one more 4. So that their count was 3. So we have to add that count as well. So because longest increased subsequence is 4. So we have to add all the counts. So here is 2, here is going to be 3, 2 plus 3 is nothing but going to be 5, so we have to return 5. But for now you understood that in this example we have only one, we can say, index where the longest subsequence is 4, that count is 2, right? So we are going to return one answer 2. And in the example also you can see, first example we are having answer. Let me just scroll over, so you can see answer is nothing but 2 only, right? Fine. Now guys, let's move to the implementation part. Let's implement it. Then you will understand that we don't need to just keep maintaining this array. We don't need to do anything else. What we are going to do, just we are going to play with these numbers and we can easily implement this particular logic, right? So let's move to the implementation. And here guys, I'm first of all with Python. So for Python, what we are going to do, we are going to say find, first of all find the length of this array, length of nums. So one, I'm going to create an array of count, which we have already seen. Count by default value is going to be 1 only, right? So I'm going to say 1 of n. Then I'm going to create an array of dp. What is dp array? You can see guys, this 1, 2, 3, 3, 4, I'm going to store in dp, right? So I'm going to say initially 1 close n. So everyone will have 1, right? Fine. Now once we have done this thing part, what we are going to do now? So we are going to say traverse over this array for I range of n. So I'm going to say for I range of n. Then I'm going to say for, let me just do this part, for j in range of I, right? So what I'm going to do here, I'm going to say for each index, I'm just going to traverse from the left side to till this one, right? So same thing which we have seen the logic, but for 3, I'm going to go till 1. For 5, I'm going to go to 1, 3, right? So same thing we are doing here. And here we are going to check. First of all, what we were checking, we are checking if nums of I is this case, right? If nums of I, what we can do, we can say, just give me a second, right? So if nums of I is less than nums of this particular is greater than nums of j. What I was saying here, guys, uh, this particular part, right? What I'm going to say here, guys, you can see, guys, here, first of all, we have this array 5, right? If our number is less than that left number, then only we are checking that part, right? We haven't checked, if you remember, we haven't checked 4 with 5, right? Because 4, there is one number present 5 which is next to 4, we can say 4, left to 4, but we haven't checked with 4 5. Why? Because 5 is not smaller than 4, 5 is greater than 4, right? So we can't put 5 in front of 4, right? It will not gonna make an increase subsequence. So same thing we are going to check here. If our number of I, nums of I is greater than, if it is greater than the left of number, nums of j, right? If it is the case, then only we can say do our logic. And in the logic part, what we are going to do, we are going to say fine, we are going to check if our dp of I is greater than dp, or we can say if it is less than dp of j plus 1. So what this going to do, this going to do, guys, nothing but we can say simple thing. It's going to tell us that if we, this number is smaller than our calculated number, then what we are going to do, we are going to say fine, if it's the case, so we are going to place it here, right? So we can say dp of I is going to be nothing but dp of j plus 1, and here we are going to say our count should be, now replace it. So count should be going to be equal to j. Count of I should be equal to now count of j, right? But else if we can say if dp of I, let me give a space for understanding. Fine. If dp of I is equal to dp of j plus 1. So this is the next condition, last condition which we have found, right? dp of j plus 1. So this is the last condition. Here you can see we are having 4, and the last number which we got, like 1, 3, 4, and 7. This is also having a 4, right? If both are having the same, if dp of I is equal to dp of j plus 1, if both are having the same, then what we are going to do, we are going to say fine. Then you have to do nothing but you have to just replace the count. You have to add the count. Count of I plus equal to count of j. Right? Simple thing. What we have done here, count of I, which was here 1, we have added this one as well. Once this is done, then what we are going to do, we are going to say fine. Once we done this thing, we are going to come out with this particular loop, right? For loop. So once we come out from this loop, we are going to say, okay, dp of I is nothing but now we are comparing with the maximum, right? So we are going to say here our maximum is going to be nothing but initially 1. So I can just simply say here maximum is nothing but we can say initially 1, right? So 1 is going to be, we are going to keep compare here. We don't need to find again any loop. So we can say simply maximum is going to be max of maximum comma dp of I, right? So what this is going to do, guys, this is going to tell us that what is the maximum value in the loop. So initially we will have 2, then 3. So we don't need to compare in the next loop by just comparing this. We just keep calculating the maximum value there as well, right? So we got a maximum value as well. Now once this whole loop will over, then we will have our maximum value, which is nothing but 4 here, right? So we need to find all the counts in the counts array where the maximum value is 4. Just we need to add this count and we have to return this. So what I mean by here, guys, I'm just going to say return sum a comma b for a comma b in our zip of dp of counts if our a is equal to our this maximum. And if I run this code, and so you can see this will wanna pass this. And what I'm doing actually in this line here is nothing but, let me show you. Okay, it's saying that return sum of a comma b. What I have done here is, it's saying that for a comma b generate expression must be essentialized. Fine. So for a comma b in this I have to just say a, right. uh, let's run this code now. And what I mean by here, guys, in this last line, I'm just saying that if our count is equal to that particular thing, just let me show you here. If our count is equal to 4, just find out in this nums array where you are having a 4. So I'm just saying in dp, if you are having, you have to traverse in dp and count as a zip, and you have to check if a is equal to maximum, means if this dp of value, if this value is equal to the maximum, here you will find 4. If it is equal to 4, then you have to take that respective count value. So it is taking all that count value. After that, it's doing addition of that, right? Simple thing, guys. If you're not getting this particular part, don't worry, let me summarize this one in a simple way. I'm just saying that for we can say I in range of n, and here just let me just show you here. If our dp of I is equal to our maximum one, right? If dp of I is equal to maximum one, then what we are doing, we are just saying that count should be, result should be plus equal to our count of I, right? Simple thing. This is thing which we are doing in this next line, right? Same thing you will do, you will find a same answer, right? So let's try to submit this code. So I hope, guys, you are understanding this part. Just main motive is to understand this particular logic. I don't have a like more interaction with the implementation part, but you need to understand with the logic, right? You can make your own implementation as well. So let's move to the next programming language, which is C++. First of all, we are going to find a length int n is equal to nums dot size, and there we are going to say fine. First of all, let's create a vector of num, vector of int data type. The name I'm going to give dp of n size, by default value 1. Vector of int I'm going to give a name is count, n size value by default going to be 1. Fine, and I'm going to give a maximum, which in a summary, we keep calculating the maximum length of longest English subsequence in a loop. So initially it will be 1, and after that I'm going to use a loop for int I 0 less than n I plus 1, and here I'm going to say for int I is equal to, int j is equal to 0 and j less than I j plus 1. Fine, and here we're going to say if our nums of I, is greater than nums of j, then only we have to proceed. And here we are going to check if dp of our I, that is greater than, no, it is great less than dp of j plus 1. If it is less than, then you have to simply replace with this, right? Dp of I is equal to dp of j plus 1, and we are going to say count should be replaced, count of I should be equal to count of j, right? But if it is not the case, else if our dp of I is equal to dp of j plus 1, right, then what we are going to do, we are going to say don't do anything, just replace the count, add a count of I plus equal to count of j. Fine. Now once this is done, then we are going to say fine, come to this loop. So we are going to say come to this for loop, and here I have used a square bracket. I will use single one, right? So fine. Okay. And here we are going to say nothing but we are going to give a space. Fine. And here we are going to say maximum should be keep updating, right? If it is greater, maximum should be equal to max of maximum comma dp of I, right? So after this for loop, we are going to get the maximum. So we are going to just say int result, which initially equal to 0. Int result which initially equal to 0, then we are going to say for int I is equal to 0, I less than n I plus plus, and here we are going to check if our dp of I, let me just use a bracket, if our dp of I is equal to maximum, right, maximum, then what we are going to do, we are going to say result plus equal to our this count of I, right? And after that we are going to simply return that result. Let's run this code and see whether it's working fine or not, and I hope, guys, it will also work fine. You can see both the test case passed. So let's try to submit this code as well. And then we are going to move to the next programming language, which is nothing but we got a wrong answer. I don't know why. Let's check this part. So what we have done wrong here, we have seen I less than n I plus plus, j0 j less than n j plus plus. If dp of I is, see, if dp of I is dp of j plus 1, so you are getting this, right? If here we haven't used equal sign, right? So we have to use equal sign. Now let's use this test case and let's try to run this code. So let's see. So it passed that test case as well. So now let's try to submit this code. I don't know why I have done this minor mistake. So you can see, guys, it successfully passed and submitted the code, right? Now let's move to the Java. And in Java, first of all, let's calculate the length. So in n is equal to nums dot length. Then let's create an array. So we can say int, and name I'm going to give first of all dp is equal to new int. Let me write a new int the size n, and int we can say count array, which is also going to be new int of n, and then we are going to say arrays to fill this dp1 and arrays to fill this count as well 1. So in these both array we are going to fill by default value 1. After that we are going to say for int I is equal to 0 I less than I forget to one thing, that is maximum initialization, right? So for int I is equal to 0 I less than I n I plus plus, and in the as for int is equal to j is equal to 0, j less than I, j plus plus. And here we are going to do some logic, right? Before that, let me define one variable, that is nothing but int maximum, which initially 1, right? Fine. Now in this loop, we are going to say if our nums of I is greater than nums of j, which means nothing but we can say nums, that means we can put this number in front of I, right? We can put this nums of j in front of nums of I. So we're going to check first of all if dp of our I, if this is our we can say smaller than dp of j plus 1, then what we are going to do, we're going to say we have to update our dp of I. dp of I should be equal to dp of j plus 1, and we have to replace our count of I should be count of j now. Fine. But if it is not the case, else if, so let me take a new line, else if dp of I is equal to dp of j plus 1, that means this is repeated one, so we are going to say dp of j should dp of, we don't need to update dp because it is already equal, we just need to update our count. We need to say count of I now plus equal to count of j. Fine. And after this for loop, we are going to say just update our maximum if it is greater. So maximum is going to be equal to math.max. We are going to say maximum, maximum. So what we can do is fine maximum, and here we're going to pass our dp of I. Fine. And after this for loop, we are going to say we found our maximum, so we just need to traverse over this dp array for I int I raised I for in, no, we can use this thing, we have to use for int I is equal to 0, I less than n, I plus plus, and here we are going to say if our dp of I is equal to, if our dp of I is equal to that particular maximum, then what we are going to do, we are going to say result plus equal to this particular count of that I. And here result is nothing but we can say result is nothing but equal to 0 initially. So at the end we have to return just nothing but simple result, right? So let's run this code and see whether it's working fine or not. So I hope guys it should work, right? We don't want to get any error. You can see guys all the test case passed, so let's try to submit this code, and it will definitely gonna submit, right? So you can see guys successfully got submitted. Now let's move to the last programming language, which is nothing but JavaScript. So we're gonna say first of all find a length, let and why I'm keep missing this, right? Nums dot we can say length, right? Fine. After that, we are going to create two array, const our dp array, which is going to be a new array of n size dot fill. You have to fill what? You have to fill 1, right? And const our count array, which is new, which is also going to be array. So we can say array and dot fill. You have to fill nothing but 1. After that, what you are going to do? You are going to say let maximum initially equal to 1. Then you are going to use for let I is equal to 0, I less than n, I plus plus. Then again for let j is equal to 0. J less than I, j plus plus, and here you're going to say if our nums of I is, if it is greater than we can say nums of j, that means we can put this number in front of nums of I, right? So we're going to check if our dp of I is less than dp of j plus 1. If it is less than dp of j plus 1, then what we are going to do, we are going to say update dp of I. dp of I should be equal to now dp of j plus 1, not here, right? And count should be replaced by count of j, right? And in the else if condition, if dp of I is equal to dp of j plus 1, if it is already equal to dp of j plus 1, then what we are going to do, we are not going to update dp of I, we are just simply say count of I should be equal to count of j. We are going to add that particular count as well. Now at the end we are going to as update our maximum, so maximum should be equal to math dot maximum, we can say like this maximum, and here we can also say dp of I. So after that we are going to say fine, if it is the case, then we are going to say for int for let I is equal to 0, I less than n, I plus plus. Here we are going to say int first of all let's say result is 0. So in this loop we are going to say if our we can say result, or we can say dp of I is equal to maximum. If it is equal to maximum, then what we are going to do, we are going to say result plus equal to count of that particular I, and simply we are going to return that result. Now let's see whether it's working fine or not, right? So I hope guys it should work, right? So let's see that, and you can see guys it's successfully pass all the test case. Now let's submit this code as well, and it will definitely gonna submit as well, right? So you can see guys it's successfully go submitted this particular code as well. So guys, we have seen the implementation with Python, C++, Java and JavaScript, and we have also understood the logic part. We have also seen the problem understanding part. If you have any kind of doubt in the problem understanding, logic and in the implementation, you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.